A bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. So here the given situation. So this is a bullet. So this bullet is traveling 150 meter per second. It's having mass and it's traveling 150 meter per second. And this bullet is hitting this wooden stationary block. So this is hitting the wooden stationary block, and after 0.03 seconds it comes to rest. So this is the initial position. If I take the mass of bullet m1, the mass of bullet m1 equal to 10 gram, 10 gram which also equal to 0.01 kg. And it's traveling with a velocity v1 equal to 150 meter per second. And this bullet is striking the wooden block with 150 meter per second, and after 0.03 seconds, so after 0.03 seconds the bullet comes to rest. So what we need to find? Calculate the distance of penetration. So first one we need to calculate the distance of penetration of the bullet into the block. So it means from here to here how much distance. So this distance I need to find out. That is the distance of penetration. So to find out that, we will use any equation of motion. So that equation of motion will help us to find out the distance of penetration. Now here we need to write that to find the distance of penetration, we need to find the acceleration first. Now the bullet is hitting the bullet hitting the block with velocity so that is the initial velocity. So here I can take that initial velocity equal to 150 meter per second, u equal to 150 meter per second. And after traveling time in block t equal to 0.03 second, the final velocity of the bullet final velocity v equal to 0 because it comes to rest. So if it comes to rest, the bullet final velocity equal to 0. It stops. Now we use the first equation of motion. By first equation of motion, v equal to u plus at. So here substitute the known values what we are having. So final velocity equal to 0 and initial velocity equal to 150 times a acceleration t equal to 0.03. So from this try to get the acceleration a equal to minus 150 upon 0.03. So this we can write it as minus 150 upon 0.03. You can write that 3 upon 100, which equal to minus 15,000. Am I correct? Yeah. So this is 15 times 2 zeros upon 3. So 3 15, it gives the 5. Therefore acceleration A equal to minus 5,000 meter per second square. So this is the acceleration of the bullet. So here acceleration is negative. What does it mean? So the negative sign minus sign, the negative sign shows the bullet comes to rest. So that's the reason after hitting the block, the bullet is coming to rest. The negative sign shows. So here we calculate the distance of penetration of the bullet into the block. So to calculate the distance, now we will use third equation of motion. From third equation of motion, that is v square minus u square equal to 2as. So in this one I need to find s. So final velocity equal to 0 square minus initial velocity, that is 150 whole square equal to 2 times acceleration minus 5,000 times s. So let us simplify it here. Minus 150 square. 150 square goes to 22500 equal to minus 10,000 times s. Therefore s equal to, you can do the division, minus 22500 upon minus 10,000. Now do the further simplify. So numerator, these two zeros gets cancelled with the denominator and negative sign also gets cancelled. Therefore s, displacement or distance of penetration, here equal to 225 upon 100. So if we can do this calculation, I can end up with 2.25 meters. Now that's the distance of penetration. The bullet is traveling inside the block. How much distance? From here to here, the distance of penetration 2.25 meter. Now in the given question, one more thing we need to find, that is also calculate the magnitude of force exerted by the bullet, by the wooden block on the bullet. Calculate the magnitude of the force exerted by the wooden block on the bullet. So to calculate that, first I will calculate the force exerted by the bullet, since I know the mass of the bullet and acceleration of the bullet. Therefore force exerted by the bullet. So we know the formula, F equal to ma, mass times acceleration. So force equal to mass, I got that 10 gram, that equal to 0.01 kg, and acceleration, that is minus here 5,000. 5,000 altogether units are newtons. So if we multiply this, F equal to 0.01 and 5, so I can get that negative 50 Newton. So according to Newton's third law. What is Newton's third law? For every action there is an equal and opposite reaction. So if this is the force exerted by the bullet, now the force exerted by the wooden block is also same in magnitude, that is also in 50 Newton, but opposite in direction. So that opposite in direction we represent as positive. Since bullet force is minus 50 newtons, but we need to calculate the force exerted by the wooden block. So this we are using at here Newton's third law. So according to Newton's third law, so if the force is exerted by the bullet equal to minus 50 newtons, now this is supposed to be now the force exerted by the wooden block. So this force is also equal in magnitude but opposite in the direction. So that's why we take it out the negative sign. So this is the amount of the force which is exerted by the wooden block on the bullet. Let's try one more problem. An object of mass 100 kg is accelerated uniformly from a velocity 5 meter per second to 8 meter per second in 6 seconds. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. So here given a mass of 100 kg. So this is, I consider a mass of 100 kg. So its initial velocity. Mass is given 100 kg. And initial velocity. Initial velocity, if I take u equal to 5 meter per second. And final velocity v equal to 8 meter per second. And time to change the velocity, I can represent that as symbol time. Time t equal to, what's that, 6 seconds. What we need to calculate here? First we need to calculate the initial and final momentum. What is initial momentum of the object and what is final momentum of the object? Let's calculate first initial momentum. So initial momentum, if you can take that as p suffix I, initial momentum equal to mass into initial velocity. So that is the initial momentum formula. So initial momentum p suffix I equal to mass is given 100 and initial velocity equal to 5, units will be kg meter per second. So initial momentum p suffix I equal to, its value becomes 500 kg meter per second. That is the initial momentum of the object. Now in the second case we need to find the final momentum. Now calculate the final momentum. Final momentum p suffix f equal to mass times final velocity. Now substitute the two values. We are having mass, so momentum final equal to mass is given 100 and velocity, final velocity 8, so units kg meter per second. So momentum final equal to, if you multiply, it becomes 800 kg meter per second. Now apart of that, what we need to calculate? We need to calculate one more thing, that is that find the magnitude of force exerted on the object. We need to find the magnitude of the force. So according to Newton's second law, if you remember, force is nothing but F equal to ma, mass times acceleration. But we don't know the acceleration, so we can write acceleration from first equation of motion, acceleration A equal to V minus U upon T, which equal to A. Therefore force F equal to mass times V minus U upon T. So I hope we are having all the values. Yeah, mass equal to 100 and final velocity equal to 8 and initial velocity equal to 5 and time equal to 6. So let us simplify here. 100 times, so it gives 3 upon 6, which also gives 1 upon 2. So force F equal to, if we can do this cut, 2 in 100, again 50 times. So force F equal to 50 Newton. So this is the force exerted by the object. So here remember, in the place of acceleration we use from the first equation of motion. So here I can mention from Newton's second law. And at here from first equation of motion. So finally, the force exerted by the object, the magnitude of force exerted on the object equal to 50 newtons. The magnitude of force exerted on the object F equal to 50 newtons. Yeah, let's try one more problem. How much momentum will a dumbbell ball of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter? Take it downwards acceleration to be 10 meter per second square. Suppose this is a dumbbell. So this is a dumbbell. So you know that this one is used to do the exercise, dumbbell. So the dumbbell is 80 centimeter above the ground. So let this take as ground. So this is 80 centimeter above. Above the ground. Now this dumbbell is falling, so it means it will fall on the surface. It will fall on the surface. When it falls on the surface, we need to calculate how much momentum is transferring to the floor. We need to calculate this momentum of the dumbbell. Momentum of the dumbbell. What is the momentum formula? Momentum P equal to the product of mass times velocity. So we know the dumbbell mass. Dumbbell mass equal to M. If I take that 10 kg. Dumbbell mass is given 10 kg. But we don't know what is the velocity of dumbbell. Dumbbell velocity V equal to how much? This we don't know. First we need to find that dumbbell velocity. So So how can I find the dumbbell velocity? By using third equation of motion. So we know that from third equation of motion, v square minus u square equal to 2as. So here v equal to final velocity. So final velocity, since it is touching on the ground, so final velocity v equal to 0. Dumbbell final velocity. And initial velocity u equal to, final velocity we need to find. Final velocity we need to find. And initial velocity, since it is not dropped, dumbbell initial velocity, we take that as initial velocity equal to 0. And acceleration is given that 10 meter per second square, that's value is given. And dumbbell, S we need. S is distance between the ground to the dumbbell. So that is mentioned that 80 centimeter. 80 centimeter, if you can convert that in terms of meters, so that will becomes 0.8 meters. So this is given 80 centimeters, so I can write that as 0.8 meters. So these are the values: initial velocity v, and acceleration a, and distance s. So by using these values, let's try to substitute these values at here. These are all values in this formula. So final velocity v square equal minus u square value equal to 0 square equal to 2 times 10 times 0.8. So therefore v square equal to, if we can multiply that, that becomes 1.6 times 10. So v square equal to 16. And v equal to under root 16, which equal to under root 4 square, which equal to 4 meter per second. So this is the final velocity of the dumbbell. So I can mention that at here, the final velocity of the dumbbell v equal to 4 meter per second. Now calculate the momentum. Therefore momentum of the dumbbell, so P equal to mass times velocity. Therefore momentum P equal to mass is given 10 kg. Mass is given 10 kg and velocity here I got 4. So momentum, total momentum P equal to 40 kg meter per second. So this is the amount of momentum which is transferred by the dumbbell on the floor. So that we can write it down. Therefore the momentum transferred by the dumbbell to the ground, P equal to 40 kg meter per second. So this is the required answer.